This
joined.
conference will now be recorded.
Okay. um, I'm joined with Tom Stafford. We both work in the Fusion Splicer lab at OFS Fitel. So yeah, that's just a quick little short intro.
Yeah. And then we're lucky enough to have, I thought Tom was not going to be able to join us today, but he's on via call. So if we have any questions for Tom specifically, he is available. So thank you for joining, Tom. Do you want to take a moment to introduce yourself, sir?
Oh, yes. My name is Tom Stafford. I work with Andrew at the Norcross plant. I'm a field service engineer. Been with OFS Fitel for 21 years. Been with the Fusion Splicing group for 10 years. So we know quite a bit about the rollable ribbon and all the technologies. And we'll let Andrew take it from there. I'm on the road today, traveling back from a client site, so I'll have limited access.
Thanks, Tom. Appreciate it. And also for the folks that are participating, Andrew has indicated that he's more than happy for any questions that you guys may have along the way. If you'd like to use the chat box, we can moderate those questions, and as we come to a stopping point, I'll interrupt Andrew. But if there's something that is pertinent to the discussion we're having, feel free to chime in. Hopefully it won't get too busy, but we've got some interesting material. So Andrew, without any further ado, please take it away.
All right, we'll jump right into it. Like you said, if you have any questions, feel free to jump in. This is half PowerPoint, or hopefully less than half PowerPoint, and the other half hands-on. So feel free to stop me. All right. So this first slide, I'm going to start off rough. It's pretty intimidating, but it basically is covering the whole spectrum when we're talking about fiber solutions. What does that really mean? It's the complete package between how providers have designed their ribbon, the ribbon counts and sizes, ribbon structures, and then how to splice that together. Every manufacturer has their different method of not only making the ribbon or making the fibers, but also how to bring them together in different splicing methods. And within that, there's specific items that need to be modified, specifically when you're talking rollable or 200 micron. The fiber holders, the thermal strippers, even down to the cleaning liquid can all make a major difference. And we'll get into that in a little more detail further on. But the protection sleeve, the main providers are OFS, Fujikura, Sumitomo. As far as for the Fusion splicers are concerned, and Ilsen Tech are in there for the flat ribbon only that we know of right now. Then you also have a little bit different operation. When you're dealing with flat and rollable, there is a little bit of difference, and we'll walk through that. Ribbon design, we'll go into that a little bit more specific here in a minute, but Corning, Prismium, Sumitomo, AFL, OFS, Fitel, they all have a little bit different structure. Then you get into ribbon sizes accounted, the 200 micron that he talked about earlier, but also the numbers, the 4, 8s, 12, 16, and then flat, rollable, and how they're bonded together. There's different methods, and we'll go more into detail. So it's a lot of information, but that's all of this is what goes into getting adequate splicing performance and also handling the ribbon fibers. All right, let's click through this. So we're talking specifically about 250 and 200. When we're talking about the 250 micron fiber, the secondary coating is at 250, and 200. The actual glass is actually at 125. So the size of the actual fiber does not change. It's only the outside coating. And this was just kind of to show you the ribbon structures, the traditional loose tube versus flat ribbon and rollable. In our case, it collapses. So I won't bore you to death with death by PowerPoint. Let me get through all these clicks. So the splicing platforms definitely require flexibility. As you can see, you know, you can have 200 to 200 flat, you can have 250 to 250 flat, you can do 250 to rollable, and all these various combinations. And as far as what we're concerned is, how do you bring it all together? Yeah.
Just a quick question, Andrew, and this may be a question for the audience too, but are we starting as a general trend to see more 200 micron in the rollable, or are we seeing a fairly good mix? Is it still primarily 250 micron that's available? I know with Prismian, a company that the manufacturer that we work with, they are introducing new 200 micron fibers regularly. Is that something that you guys see a lot of or anticipate seeing?
We've only really seen one manufacturer focus on the 200 flat ribbon, and that would be, I believe, the Corning Rocket ribbon is 200. I think that they're really the only ones that have gone that method. Everybody else, when you're talking about 200, with the exception of AFL, and I'll get to that in a second, have gone at a 200 rollable approach. AFL has gone their 200 at a rollable approach, but theirs is even more complicated. It's 200 in the physical size, but it's 250 pitch. So it's basically the same width as the 250 micron. And that's actually
tricky.
Yeah, it's hard to explain, but it is very important. So when AFL specifically says we have 200 micron ribbon, it's actually pitched out at a 250. So as far as splicers are concerned, it's 250. But as far as cabling is concerned, it's 200. So to make that nice and easy, so that's kind of where we're getting into here is the specifics of the fibers. So OFS, Fitel, we're same company, and Furukawa is our parent company. What we do is we bond individual ribbons. So we just have one singular bonding point between, spaced out very short, which allows ours to roll up. Because we only do a small bonding point, it allows us to be very small. The Sumitomo, on the other hand, what they do is they take an already 200 micron matrixed ribbon and actually have little knives that come and cut these out. So when you're dealing with this, you'll notice there is a matrix material. Even after you strip it, you'll see little pieces fall off. Fujikura is somewhat an in-between. They have this similar type method with their bonding, but you don't see as much of that that coating. It's similar characteristics to the Fitel, with the exception of the 200 micron is the same width or similar width as the 250. It's just their bonding points are a little bit larger to compensate. So any questions on the fiber itself? This is where you get into everybody's kind of has their own thing. I know that, like you said, Prismium, I haven't quite seen their ribbon yet, but from what I understand, it's very similar in nature to the Fujikura, and that there is some matrix material, but it's not as thick as like the Sumitomo.
Yeah, that's correct.
Okay.
The key takeaway for folks that are on the call is that there are no simple ways to state that there's 200 micron or 250 when it comes to ribbon. We really need to talk about the construction of the ribbon fiber and between the different manufacturers. So even when you're sitting down at the splicing table, it is going to be beneficial for you to understand the ribbon that you're actually working with and how it's put together, because they're going to have some different I guess tendencies or ways that you can splice them. So just wanted to make sure that we're all on the same page there.
Yeah. Yeah, that's the nice way to say it. Not all ribbon is created equal.
Yeah.
When you get there, you definitely want to have whatever splicing machine you're going to use and get samples of this ribbon. And just because you're used to one doesn't mean that it's particularly going to transfer over to the other. It's a newish technology. To everybody's trying to differentiate, and in that you want to make sure that you're set up for the best. And with that in mind, the reason that it is so important is that, I just want to go over the quick basic, mass fusion splicing process, because when we're dealing with these different types of ribbon, there is no alignment mechanism, right? So everybody says, it's a clad alignment. It actually doesn't align anything. The only alignment is actually in the V grooves themselves. So as you get different structures, as you get different widths, especially the 200 to 250, you need a different V groove. You may need different holders, but this is what's important. This is the only alignment. So that's why knowing how to handle it and having the correct equipment to handle it is so important. And this is just a quick little overview. But yeah, so when they're saying it's alignment, it's technically passive alignment. All it does is push them together.
I've gotten a question. This is John Cotter from SNS Solutions. I've got a question for you. Eric and I have both noticed this when we were demoing fusion ribbon splicing, and that it's the outside pair or outside two never seem to be the same. They're higher loss than the indoors ones are. Have you seen this before? Somebody told me this is natural.
Is this with which it shouldn't be natural anymore. I know in the past there have been people that have kind of that have had that happen. In our testing, usually at least 1 in 12 fibers have actually been fairly consistent. What causes that is basically as their fibers are pushing together, they'll jump because they're on the outsides. But I don't notice that's not really, it's not usually because of an arc or anything like that. It's usually
is that the fault of the fiber itself, the manufacturer of it?
What I'm thinking happens is the old thermal strippers, a lot of times you had to put a lot of pressure on them, which will cause those fibers to kind of naturally want to spread. So now your end fibers are going to hang over the V groove, they're not going to want to fall perfectly in.
Okay.
So as it's doing that push, it slam it together. That's kind of why we redesigned our thermal strippers, and so that you're not having to put an extraordinary amount of pressure, because all it's doing is fanning out those fibers, and it does pose that risk.
Does this have anything to do with the different manufacturers? Does some work better than others, or so you could try that? Or
I can see how the end fibers would be the most vulnerable if there was a heat. I can't say that we've tried a lot of other vendors' fusion splicers. You'll probably be safe with, the Sumitomo, the AFL, Fitel. When you start getting into Eno or something like that doesn't really have perfect access to a lot of fiber, they might be burning up some ends. And you gotta think too that every manufacturer, especially like Fitel, and OFS, we've designed our stuff to work the best, obviously, with our fiber. Sumitomo's the same with theirs. AFL's done the same with theirs. So there may be some variance in there. But usually, if it's the 1 in 12 fiber, I would think that it's probably arc calibration or that's thermal stripper. But
okay, and is this Eric? What are you seeing? I see like maybe everything in the middle range to the end about maybe 0.01, but it's the outer ones can be like as much as 0.04 sometimes. You seeing that, Eric?
No, it depends, and I think what Andrew's point is that especially with the outside ribbons, you have additional friction, and they're just by virtue of physics, you can't get the same clamp pressure on the outside as you can on the inside. So as the fibers move together, you're going to be seeing a little bit more movement on those outside fibers, so that could have some impact to the alignment during the burn phase. But
we're talking a 0.04 when we're talking just these passive alignments, a 0.05 on average, and that's single splicing. So if you now think of mass fusion splicing, typically anything under a 0.15 is considered good, at least industry-wise. So .04 to me is, yeah, there could be a little heat variance, but to me that's still a fantastic splice. It's just the nature of that passive, it only pushing them together, and as Derek said, the fibers pushing together, or just the pressure on the outsides. So, because like I said, with this, all it does is it can join the fibers using surface tension, but if they're off just a little bit, it's still going to give you that like .02, .03, .04 loss, and that's not bad. If anybody that thinks this should be doing .02s all day, or zeros, that's core alignment territory.
Well, when you're used to 0.01 from your machines almost consistently, it's a little unnerving to see that.
Right. It's a whole different application, right?
Yeah.
So I wouldn't, the fiber like this hasn't really made it to, the long haul. It's really not going to. In data centers and stuff like that, they budget for it. That's a great point though, that people need to understand that these mass passive alignment, a .05 on average is what we say, but really the industry standard, and that's pretty tight criteria, is a .15. I've seen it anywhere from a .25. It's just the nature of it. You'd be spending if you want to get .02, you'd be spending all day just on one ribbon.
Okay, thank you, appreciate it.
Yep, different applications. So, and with that comes the criteria. So when it's giving you the estimated losses, they're good reference point, but don't take them to the bank. I wouldn't say, okay, if it says it gave me a .02, that it's a .02. The only things that these machines can look at are cleave angle, gap, and axis offset. The cleave angle is just what it says. It's the cleave angle across all 12 fibers. The criteria, because of it's all 12 fibers, is a little bit higher. The gap, the distance between the fibers, and if you'll notice sometimes if you do a cleave, there may be the end fibers may be closer or further away, but a consistent gap is important. And then the axis offset, and that's how far apart these fibers are height-wise. So as far as what you're looking at, and so those
would
are
that be similar to, pardon, Andrew, would that be similar to the alignment of the core itself, the axis offset, how well aligned the cores are, or I guess the cladding of the fibers, since we're aligning the cladding?
Right. In this case, yeah, it's referring to the alignment of the cladding, because since it cannot see the core.
And then one follow-up question on each of these criteria. What is a good range that we're looking for say, cleave angle? We see those numbers pop up, like fiber 1.11 versus .47. Is there a good range that we're looking for generally if we have a fail, or if we need to go back and recleave?
So I always start with, and this is from Tom, there's nothing better than your eye. The machines are great. But your eye, if you notice something odd with a cleave, pull it before it splices, redo it. It's much easier. But as far as actual cleave angle, it'll error out anything over 3. What we recommend in the lab is anything under 2 or right around 2 is considered good. When you start getting into the 5s, 6s, you're getting pretty jagged cleaves. Gaps, there's a range. It kind of depends. It changes based on 250 or 200. In that case, the only thing that you could really do with that would be make sure that your holder is seated well in the cleaver. We'll go more into that specifically with what we've done with our cleaver. It used to be, you can see sometimes they'll come in jagged. If you ever see that, it'll error out. The only correction for that is, either rotate the blade or make sure it's seated well. Axis offset is cleaning. You can even see with these, it'll error out right around 7. Just the nature of it. A 7 on a single fiber splicer would do terrible, but because of this surface tension, it actually pulls them in closer together. So what we recommend here is probably anything under a 3 or 4 is considered good. Anything above that, you're starting to push, you can start getting a little bit higher losses, like in the 1.5s and 2s or .2s. So I know that's a convoluted answer, but it kind of just depends on what you're trying to do. In a lot of like our data center applications where we want great loss, I'll say 2. I'll say let the machine decide for the gap, because the gap is almost uncontrollable. And then the access offset will probably knock that down to 4 or 5. So that's if you're trying to shoot .1s.
And are all of these criteria something that we could set on the M24? Is that a preset range?
They are adjustable.
They're adjustable. Great.
Caveat with everything is the more you adjust it, the more you might see errors. So if you adjust it too low, you're going to be spending all your time cleaning for a little bit of gain. So
right.
They are adjustable, which is nice.
And there is a reset as well.
Yes, always.
Great, thank you.
All right. And so back to the kind of the fibers, and our solution for it is the 124 M12 with a removable V-groove system. With that, we can handle the 200, 250, and even single splicing. You can put a single fiber in there, but if you've ever done a whole bunch of single splices with a 12 fiber V-groove, or you don't have very good vision, that's a tough one. So that's why we have the separate V-groove available. You still can do it on the 12s, but find it a lot more consistent, or just easier to see with the single. So our whole thing is it's right now it's 3 machines in one. Soon it'll be 4, 5, as we start adding different V-grooves, which is kind of the nice thing. We're not done yet. When we got 16 fiber coming, 80 micron, there's a whole bunch of stuff in the works. So with that, it was re-engineered to have removable V-grooves. Honestly, a 2-minute change-out process would be extremely slow. It's simple. I'm going to do it in front of you. As far as in the past, one of the issues people have is obviously those offsets, because all it's doing is pushing those fibers together. When those get dirty, people get frustrated. Before you couldn't take them out, now you can take it out, put it in an alcohol bath, scrub it, whatever you got to do, which also reduces the trips into the lab. We do repair, Tom and myself, and 90% of what we get is cleaning, and more so, a higher percentage of that is cleaning when it comes to M12 machines, because really there's only the V-grooves to worry about.
Something to note too on your criteria, the offset, we're talking microns here, that the offset has to be within. So having that clean, absolutely no dust or dirt, debris, oil, anything on the V-groove is really going to make the difference between what do we have there, at 1 micron versus 3 micron gap or offset. So
I think Tom said, what was the size? If you can see a piece of dust, wasn't it like 25 microns? Is that correct?
Yeah, I think it might be 25, 30 microns. Yeah, so you just think about that. Just to see that with your bare eye, it's got to be that big, and we're talking about 3, 4 microns, as a very large offset, and so it's very, very important that they're clean.
So if you tell me they look clean, I'm gonna kind of go, okay. They expect them to look clean, but there still could be something in there that's 15 microns in size.
Well, 4 microns is half the size of the core, roughly, almost. 4.5 micron would be half the size of the core, so it'd be halfway off.
So if you can see that, you might, eagle eyes.
You got some good vision.
Yeah. So, obviously we've taken steps with our machine to be able to handle various types of ribbon sizes, ribbon counts. We do have holders for, 2, 4, 6, 8, 10, 12, and 16. But one of the major operations, and this is where we were talking earlier about the thermal stripper causing those fiber ends to kind of splay out. With our S218R200, it's actually been redesigned to cover 200 and 250, rollable and flat. So it's pretty much an all-in-one kind of thermal stripper. They increase the heat a lot. They increase the blade intrusion quite a bit, so you don't have to muscle it down. It was that extra pressure that was causing fibers to kind of splay out a little bit. It's a simple to use. I'll kind of walk you through it. The only thing to keep in mind between flat and rollable is you got to brush it out every time with rollable. I don't care whose rollable or pliable or spider web you use, you need to brush them out every time. They'll build up debris and then you'll get bad strips and you'll get angry. There's an optional stand too. So if you're in the same spot every time, they find using the palm of your hand to be a lot easier than pinching on it. It's a lot less pressure too. So
a question for you: Has this the new stripper? How long has that been out?
This one has been out at least a year.
Oh, okay.
Right around a year.
Yeah, I don't know how old our demo is.
What color is your demo? That'll tell me.
Eric, do you remember?
I couldn't tell you. I have a new R.
What would we want to look for if the color is criteria?
This blue color right here, and if it's the pink one, or if it's the yellow one, or if it's gray or black, this is the color you want to look for. This is the all-in-one. We do have an S218R Plus, which is meant for 250 only. So it's 250 rollable, 250 flat. But this one is designed to handle everything. And this is the one that's just to me, it's just better.
Okay, we'll look for that.
And we've used label. Go ahead.
Blue label, right?
Yep.
Okay, thank you.
All right. Moving on to our cleaver, the S326R. With our cleaver, it's a simple one-step operation. If you're used to some of the other cleavers, it does come in from the other side. It can easily be flipped around. You can use it either way. Automatic waste fiber collection system. The anti-static waste bin, if you've done a lot of ribbon fiber, you will appreciate how much of a difference this will make in your life and in your pockets and in your getting stabbed by fiber. It works, and it works well. The fibers end up in the waste bin where they should be, and not in, all over the cleaver in your hands. We've also introduced a pusher. What this does, it references the holder into the corner, and that's where remember the gap. The biggest thing with gap is to be consistent. If you have the holder in there at an odd angle, there's chance that it'll either cut it at a progressive angle, or that it'll kind of make the ends jagged. This will reference everything and cause nice even cleaves. With that, it's simple to use. It's lightweight. Blade rotation is manual, but it's simple to do. Blades are replaceable. Once again, pretty simple to do. It's the same screw. And we'll kind of walk through all that. But anti-static waste bin, I promise. So once again, it's the sum of all the parts. That's the main thing when we're talking rollable in any fashion. It's the sum of all the parts. If you're missing any one of these steps or any one of these pieces, it's degrading that final product, and even to the point where it may seem unusable. If you say, well, I got an old thermal stripper and I'm going to use that, but I'll get everything else, it's not going to work, or it won't work. It won't work well. Even down to the fiber holders. So Even the fiber holders have been redesigned to have twice the clamping power, which, you know, sounds fancy, but it really, it's a necessity. When you're using the thermal stripper and pulling fibers through, these don't do that. They're specially designed to make sure the fibers stay in place, even with our small rollable. And the one thing that you guys had talked, oh, go ahead.
Andrew, quick question on the fiber holders or the cleaver. Is the S326R compatible with the Fujikura fiber holders? I don't think so, but is there compatibility across manufacturers at all? I'm sure that's not something you guys recommend, but I don't know if they're designed as such.
Tom, do you know that? Because I believe that they are compatible. As far as my understanding, the shape of all the fiber holders are the same. It's the pin design that's only different, really.
Yeah, I believe that they will work. I don't think they all have the pusher that like we've got on the 326R to reference it really well. So that would be the recommendation to control the gaps with 326R having that pusher. But I think they will work though.
Yeah, there may be some kind of compatibility if you're using like a, you know, I mean, our holders working in other ones, they should work fine. The only one that I would worry about is the pitch conversion holder, just because it's a little bit wider. So there may be, you know, a little bit of difference there. But other than that, there should be some cross compatibility. And speaking of pitch conversion, I know that was one of the big topics that you wanted to hit today. So we have, if you're going down the normal path, you know, fiber in the holder, thermal stripper, clean, cleave, splice, protect. If you are pitching out 200 to 250, if you run into a situation where on one side you have your 200, the other side you have 250, you have to expand that out. To do that, first you separate the fibers, place them in the holder, and then you treat it like normal. It's not a very long process. We'll walk through it. I'll demo it. And the other thing to note here, okay, since this is the last one, is the reinforcing. So we have a specially designed sleeve to handle rollable ribbon. There isn't really a good picture of it here, but with this shape, rollable ribbon tends to follow the pressures that are applied. For here, it'll follow this outside. So all the fibers will stay nice and neat on the outside of this. On the old style ribbons, the pressure will come in and actually cause the fibers to cross over or pinch. Yeah, just should have gotten the picture of it. I've got a pretty good picture of it somewhere, but even the sleeve makes a difference. And if you've done any rollable, you'll know what I'm talking about. You'll have seen it. The fibers crossing over, it doesn't look good in the sleeve. This will stop that, and it's not like any crazy more expensive. It's just basically the centerpiece is flipped over.
And will the flat ribbon work okay with those protection sleeves?
Yes, it will.
Okay.
I mean, it's not an extraordinarily difference in cost or anything like that, but it may be easier if you already have a bunch of old sleeves lying around for flat to keep with the typical ones. But there should be no problem with this. It doesn't put a heavy, it's not a heavy, you know, what am I thinking? But
bend or crossover, yeah.
Yes. Yeah.
I've handed out a few of the those sleeves to customers for sample or what have you, and that question came up, is like, does this work okay with my existing flat? There are a lot of our customers are looking at the transition from to rollable or to a smaller fiber, so that's where we're wanted to highlight the capability of the machine to be able to kind of handle all those various different situations, so that you guys don't have as much concern or trepidation about bringing some of these new fiber types into your network, because the tools are available to make them work all together.
Right. And one of the great things about this is it's all backward compatible. Mm-hmm. So we've got, the sleeve should, there isn't really an issue with flat ribbon. Machines will handle flat, the cleaver, the cleaning, the thermal stripper, holders. You know, we do have a separate set that we recommend for flat. It's just, for us, it's just easier, and you probably already have it. But all this is, you know,
oh, and single fusion. Don't forget, we can do single fusion with those as well.
And single fusion, yeah. And most likely we're able to handle everybody else's stuff a little bit easier, just because our fiber design. So without any further things, I just put up here for our landing page. So if you have any further questions, or you know, do want to look into, we've got videos, we've got data sheets, instructions, operation guides, whatever, RMA creations if you broke a machine, and technical support. So our contact information is all up there. Just kind of another resource for you.
So we will be able to provide this slide deck out to all the participants today, so you guys will have this as a link. But I just checked, you can just point the camera on your phone right at the screen, and it'll take you right to the website. So that's a pretty slick.
And that's constantly being updated. And if you have suggestions, I'd be the one. Send suggestions. Love suggestions. If you have anything that you want to see, video-wise, or you think is unclear. We're always willing to work with customers, so just want to throw that out there.
So for all the participants, before Andrew finishes with the presentation, we move over to the live demo. Are there any questions that anyone has about some of the topics we've discussed, the various different fiber types out there? Even if you have any anecdotes about some situations that you found when you're splicing ribbon, or if you have questions about ribbon, throw them out there. You can either hit us in the chat box, or if you want to unmute, looks like most everyone's muted, feel free to just speak up. All right, great. Well, no questions, it seems like. Andrew, if you want to give us a, perfect.
Yeah, right into it. Let me close that out. All right. So for the live demo, turn on lights.
There we go.
Much better?
Yes, sir.
All right. So what I've already done, just as a quick thing, is pre-prep fiber. So Tom will know the one thing that we hit on, and I'm sure you know as well, arc checks, arc checks, arc checks. They are a little bit, I hate to say this, they are a little bit less important when it comes to ribbon splicing, but they still are important. If you're not doing them every day, you should be doing them every week. So the first thing I did was obviously prep up some fiber to perform an arc calibration, just so I can get everybody started.
One thing to note too, I think the importance of the arc check increases if you change fiber types, or if you're using the same fiber that you used last week in the same temperature and same humidity, you may have less necessity for an arc check. But if you change fiber types, whether it be manufacturer or rollable or flat, and you also change your humidity and elevation, then you definitely want to arc check.
And to add on to that, Eric, also very, very important, if you go from the 200, Andrew's going to show you how to pop in a 200 V groove or 250, very, very important. The arc condition is totally different between the two, to make sure that we do the arc check. That might take a few, since the arc condition is so different, to get it to pass.
Yeah, and I didn't mention as well, if you're removing those electrodes, or manipulating the electrodes in any way, is probably going to be a good time to arc check as well.
Yeah, anytime you clean, the electrodes, or even the V grooves for that matter, it's always a good time to arc calibrate. If you're getting high loss and everything looks good, it's more than likely that you didn't arc check. That's the symptom. So with that, I did my arc calibration. And I had just switched over from 250 to 200, so I knew I needed to do it. All right, so now we're going to get into the actual, I'm going to do a 200 to 200 splice with all the preparation. All right, and then I'm do a 200 to 250 splice after this. So first thing you want to do is obviously put fiber in the holder. About an inch, inch and a quarter. Go back. That's it. There you go. Just like that. From there, you want to put it into your S218R200 thermal stripper. This one's already been turned on. The main thing with rollable of any sort is to make sure it's flat in all parts of this process. I even make sure it's flat in the thermal stripper. Close it, wait for it to turn solid green. Pull. There you go. As you can see, I didn't put a whole lot of pressure. I wasn't struggling by any stretch of the imagination. I should not have done that over the top of the machine. Tom will get me for that later. You don't want to strip over the top of your open machine. That's a terrible, terrible habit. Yep.
One thing too, while you've
only got so much frame width to work with.
Yeah, one thing to note too for the folks that haven't worked with rollable ribbon, it is a unique design, and you find that even just pressure between your thumb and index finger will help to flatten that ribbon out. And of course, and one of the challenges that Andrew highlighted before is you do want to, make sure that you have your color alignment. A challenge with the flat ribbon, of course, everyone's, blue to blue, et cetera. But also even with the rollable ribbon, you definitely need to pay closer attention. It is a little bit more delicate of a splicing operation versus a single fusion on a core alignment machine. So as I like to tell a lot of folks, if you're doing a 144 cable and ribbon, it's not 1/12 of the time. It may be 1/2 to 1/3 of the time because you're doing 12 burns versus 144, but you do definitely need to take a little bit more time during the ribbon splicing operation to make sure that everything's lined up correctly.
Correct. So I wanted to show you guys this too. So this is just the one strip. Believe it or not, this is one of the cleaner strips of the comparable rollable or pliable or spider whatever ribbons, but you still need to brush it out every time. I personally like to use Amazon's Finest $1 grout brush. No real preference there. Once again, lay it in. I use my finger. You should probably use a Q-tip. It's pretty hot. But you want to make sure that they're laying pretty flat. This one's going to take just a little bit longer since I talk too much. There you go. Solid green and full. From there, prep fluid and a wipe. I strongly recommend prep fluid and a wipe for this, especially when you're working with 200. It's closer together. It's going to want to stick together. It's going to want to cross over a lot more, just like flat ribbon, but a little bit more. So having a good wipe, having good prep fluid will help keep the fiber separated. The straighter you can clean it, the easier it'll be to lay it in the cleaver. There we go. Laying it in, I'm coming in at a little bit of an angle for that pusher. So the little technique that I use is I just tap these ends that are going to get cut off, make sure they're flat. If they're crossed over there, there's a good chance that the blade's going to hit all of them except for that one because it's being lifted up higher. Once again, everything is making sure that the fiber's flat. Close the top, so it clicks, hold the back. There you go. Sleeve complete. Move it from there.
Andrew, I have to do a shameless plug for one of our other products, but I definitely find that the this quick clean product from Polywater, I don't know if you guys can see on my camera, it's a
That's
QK or quick clean, is it's a ether based product over an alcohol based product, so it does evaporate much faster, and I find that that is helpful with ribbon, so you don't have any of the cleaning fluid between the fibers. So it's something to consider. That's definitely a little bit more expensive than your anhydrous alcohol, but it definitely can help, and it's a little more aggressive for actually cleaning fiber interfaces as well. Yep, that's the stuff.
Yep, we got it too. Yeah, that's it's good stuff. I've tested both. I do like the quick clean. It's a little bit different. Yeah. But definitely when it comes to the alcohol, what does Steve always say? It settles at an 80-20.
Right.
So you basically try to splice water. So, all right.
Yeah, and for the guys that are out there buying the alcohol from the Walgreens or what have you, it's probably not going to cut it for ribbon splicing. If you're moving into ribbon splicing, you probably want to get a product that's dedicated for that.
Yeah, and you'll notice too, because you'll see, 10 times the amount of buildup on your V grooves. That buildup is what causes offsets. It'll cause all sorts of problems. Electrode tips will get corroded. And that's the deposit from that water. So yeah, especially with these long, heavy arcs, it's more important to use the correct kind of fluid. 60% alcohol won't do it. A bottle of tequila won't do it. Right tool for the right job. So in this case, once again, cleaning it, you can hear it squeak.
The question I have is, Tom, have you used any white moonshine for cleaning down in those parts?
We don't have that in Georgia.
Yeah, we wouldn't waste it on fiber cleaning, that's for sure.
Yeah, we wouldn't waste it on glass. Yeah.
All right. Here. More of the same, just cleave the other side. We're dropping it in like an airplane landing. You want to hit that pin, drop it right in. From there, you can set this up to do a couple different things. You can have it come in and just splice. You can have it come in and tell you a whole bunch of information. It's kind of up to you and how you set it up. For this one, we have it set up as stepping action, and that's just to see the data. Once again, because you were asking earlier how to change all that. The fully auto, so you can have it come in and just bring the fibers in a little bit. You can have it measure the fibers and give you all the data, or you can just say, I want to close the lid and have it splice. It'll let me know if there's an error. It's kind of preference. So in this case, we want to see the data. You'll notice the longer cleaning arc with the 200 versus the 250. That's by design. So here's all that criteria that we were talking about earlier. So the gap, as you saw from those pictures, I think those gaps were in the 70 range, 60 to 70. These ones were a lot higher. That's why it kind of just depends on what fiber you're using, whether gap is a good criteria or not. But what you can notice is that they're nice and even. It's not a big, the bottom fibers aren't really close and the top fibers aren't really far away. Offsets, the highest offset on this is 2.5. That's great. Once again, we recommend keep them under, probably 4, and you'll be all right. Cleave angles, we want them to be up to 2, but anything under 3 is considered good. So obviously all these cleaves are pretty good. They're all under 2.
One
Hit the green
question
button.
for you, Andrew,
Yep.
and once you go ahead and splice. But on the next one, or if you could talk about the clamp up down soft key,
Oh, so this one right here,
or
it'll
on
do
the
it
screen. Sorry, on the left hand. Can you touch that, the up down button on the screen? I know.
There's 2 ways to do it. You can actually either hit the down,
Oh, I didn't know
down
you could hit the hard key.
or you can hit the soft key right here. What that does is that'll kind of take the clamps up a little bit, let the fibers move around, and then set back down. It'll do that automatically, or you can turn that on or off when there's some offsets around 4 or 5. So as you start getting to the higher offsets, it'll automatically do that to try and correct it, and it'll do it 3 times.
So rather than reloading the fiber, you can just hit the clamp up down and it will realign the fibers. Is that correct?
If you've done a lot of fiber work before, you've probably done it to where it'll be an offset and you open the top and slam it back down and okay, now it's good. So it's basically doing that, but without slamming the lid. Which there is another feature on this that I did fail to mention. I have done it to where I've bumped the top of the machine and the lid slams closed. The fiber clamps actually don't engage until the lid is closed. So you could slam the lid as hard as you want, but those clamps are not going to touch until they actually disengage the safety.
Yeah. That's great.
Yeah, because that's always been a worry is, dropping the top too hard and breaking fibers. So just a little extra feature there. All right, and with the splice. It's a long, long arc. And this, if you've been doing a lot of single splicing, this will seem like forever, but it's using that surface tension to actually bring the fibers together. So it has a purpose. Once again, it'll go through the before and after of offsets. And then the estimated loss. Like I said, take this with a big grain of salt. 01s, 02s. It could be. I mean,
I'll take that. I'll take 01s, 02s.
Yeah, it's a barometer. If it's giving you a dot, .15 or .7, okay, then you might want to start paying attention. But if it's giving you .01s, .02s, they're probably in the .01 to .05 range, which is more than acceptable. So with that, lift up the top. I'm gonna do a little movie magic since I don't have very long pieces of fiber. I'm gonna put my sleeve on after, which I don't recommend you do. You'll be in trouble. So with these sleeves, the best way I found is kind of bundle up the fiber just a little bit. I'm doing this at an arm's length, so it's a little bit tougher. Yeah. All right. Slide it through. Find your splice point. Now, there is no real right or wrong way as far as, should that black piece be on the top or bottom. But I'd say I prefer there's that little structure rod in there, that be on the bottom. Close it, and then you can move on to your next one. While that's going, I'm just gonna replace the V-groove. And that's going to be the easiest way, unless anybody wants to see another 200 to 200. What I'm going to change it with is the 250 V-groove. Just want to show you how simple that really is. Loosen the electrode, set it aside. But I said, if this takes 2 minutes, set it aside. The hardest part is going to be the screwdriver. And that's it for removing. So when installing, just the reverse. In this case, I see something on the edge. All right. The thing to pay attention to is this little hook down here. Just want to make sure it goes right in that tab and lays down. All right. And there you go. That looks done. So once this is set in here, screwdriver.
The screw in the V groove, that's fixed in the V groove, correct? It doesn't remove completely, or is that the case?
I mean, you could if you really, you'd have to try.
Yeah.
Put your finger on it and back
But you're
out.
not going to
Other
have to
than
worry about holding on to it or something along those lines.
that, yeah, it's a captive screw, so it won't just push through or anything like that. So, and that, just put the electrodes back in. When you put the electrodes back in, there's these little tabs right on the edge, and you make sure to push them in the slot first, and then tighten down the finger screw. Because sometimes if you just do the finger screw first, this could be at an angle, and then it's all sideways. So now it's a 250 machine, other than the arc check being done. For the sake of brevity, got a piece of 250 right here. I'll show you that I'm not tricking you. Here's some 200. I don't know if you can see the difference, but the 250 is...
It's highly visible. Those 50 microns are very obvious from this angle.
Okay, good. Yeah.
Question, when
yeah.
you are arc testing, going from a 200 to a 250, is there a different setting you use on the screen for that?
Nope.
Same one?
So if you have it on single mode auto, it's going to auto detect whether you have 250 or 200.
Okay.
So you want to make sure that you're, if you're working with 250, you want to do your arc check with 250. If you're working with 200, do it with 200.
So there's a different set for the arc test on both those? Is that what you're saying?
Nope. Same. It's the same arc test. Internally, it knows what to do. So,
Okay. Thank you.
So that's kind of, you don't have to remember to change a program or anything like that. Because I'm going to do one right. I'll do one right now if you want. But let's see. So all I did was place it in the holder on the side for the 250. Same thermal stripper. Make sure your machine lid is closed. You're going to circle the top. You want it to be in that yellow area, so a little bit shorter. When I'm talking about the yellow area is right here. Close it, wait for it to turn solid. And then whenever switching from 200 to 250, just be mindful of the pressure differences. That's why it took me a little longer. I was just trying to make sure that I wasn't using too much or too little pressure. It's not extraordinarily difficult, but brush this out. 250. Prep fluid. All right. So no movie magic. 250. And this is how particular you have to be. I see one piece of coating that must have fallen on it, probably from my hands, on the ends of this fiber. Just with that, I'm gonna hit the fiber with a little bit of hand there just to knock that piece off. You don't ever want to knowingly put dirt into your machine. Be meticulous. It's a good habit. All right, so now on to what everybody wants to see, the transition. So the transition actually there's two different holders. left side, right side. So in this case, obviously, we're gonna wanna go with the left side. They both work the same way. If you got a preference, you can do it that way, but take your 200. And I think the only one I can find is our demo. We've had quite a bit of 200 interest for this. So essentially we have a complete tool that's meant for separating these ribbons out. It's just on loan right now. So take about 4 inches, use the tool, separate out the fibers. This is very important. You want to make sure they are all separated. Grab your holder. You can pull it up a little bit. Make sure they're laying flat. I'm not sure, is this coming across fairly well that you can see?
Yep.
You want to start to where it's one back, right around that inch and a quarter. There you go. All right. So from here, I want to make sure the back end is flat. Lock it down. Keep running my thumb up. Lock it down. And this is where it's technique, right? With technique, people do things differently. For me, at this point, it should already be laying in this groove. Just have to set this top down. What FEC recommends and what Tom recommends is actually bending this over the edge just a little bit and then closing it. What that'll do is make sure that those fibers sit in the groove. But this, to me, I can already tell it's already at 250 and it's going to be an easy one. It takes a little bit of practice. I wouldn't say a lot of practice, but you know, from here you treat it just like 250. Strip, clean, cleave. Everything else is pretty much the same. It's just fanning it into those grooves, making sure it's straight.
And the 2 flaps are basically to allow your hand to be able to flatten out the ribbon without it being in the way of the other flap. Is that right?
3 secure points. So
yeah,
the back end is just to kind of hold the fiber. But I did find that the straighter that you can keep this coming in here, the better off you're going to be in the end. The second one is you want to definitely make sure it's in there while your thumb's still holding, so it gives you another clamping point. And the third one, if it's off a little bit, it will give you kind of that last chance to fix it. I know AFL has something similar, but it only has 2 lids. So you kind of lose out on the opportunity for that adjustment at the end. And I think there's transitions throughout the whole thing, whereas ours starts with 200. Where it's bonded back here, that'll help you out tremendously. That way fibers aren't going everywhere. But as you can see, there really wasn't anything crazy to it. Yeah. From here, you just treat it like a normal holder. Clean it. Leave it. Lay it in the machine. So I should have arc checked, but I didn't. That's that clamp up down that we're talking about.
is it less of a concern if you're going from 200 up to 250 versus going down?
As far as the machine's concerned, 250 is 250. As soon as it's pitched out at 250, it's 250. So I should realistically do an arc check. I wouldn't normally do an arc check with a transition fiber just because the time it would take to do it.
And you're not really changing humidity or pressure or anything like that?
No, I would just take this other holder and, arc check arc check the 250 and then do the transitions.
Ah,
Just for sake of, just for sake of time. In this case, I'm gonna let it ride. Normally you would arc check, but for the sake of time and everybody's sanity. Yeah, see there's a first one, the top one, it got a little bit. Angles were good, offsets were good. No.
it's still yet for 250 to 200 transition and everything. I think that would be fairly acceptable.
Yeah, the which.
With
Yeah.
the fiber one.
Yeah, and the .08, like I said, that's not unheard of. And even that might, like I said, take everything with a grain of salt. That's probably not true. It's probably
Right.
not that high.
Until you shoot it with an OTDR or loss test, you're not really going to know.
Yeah, that's and when we test this stuff in here, we basically use a giant power meter for 12 fibers.
Right.
So yeah, so we've seen firsthand the discrepancy between the estimated, because it's only going up based off of visuals, and it can only see so much. It can't see the core like the single fiber machines. So is there any questions, or anybody want me to go over anything specifically? No questions about.
Yeah, if any folks have any specifics on the menus or any of the software on the machines, we're more than happy to run through that with you individually as well. I really wanted Andrew to kind of give us a demonstration of the capabilities of the machine. I've had a lot of folks question about 200 micron, 250 micron, and what have you. And as you can see, even though the process is lengthier than a single fusion burn, of course, it still cuts down a lot of the time. And as far as getting any of these newer fibers into your network with the right tools, it should not be an issue for anyone. And if any folks on the call are interested in seeing this firsthand, you can contact SNS Solutions. We'll be happy to do a demonstration with you, either virtually or at your office or destination of your choice. And yeah, feel free to reach out to us for any questions as well. I know Tom and Andrew, actually you can contact them directly just by going to the About screen on your Fusion Splicer and checking out the 1-800 number. Is that correct, Andrew?
Yep, that's correct. Yeah, and one other thing to consider is ribbon fiber in general, especially rollable, is now making its way into smaller and smaller fiber counts, the 12s, and it's getting closer to home. So the usefulness before used to be data centers only. The use case was pretty rare. The use case is growing. So if you don't have a fiber splicer or a ribbon splicer, you're probably going to need one. So.
Well, if there aren't any other questions from the audience, we're about 11 minutes over, but really appreciate your time today, Andrew and Tom. Thanks for joining us on the road. And like I say, if you guys have any questions or want to see this in person, definitely reach out to us and we'll be happy to assist. Thanks everybody for joining.